back to intermediate algebra, algebra 2. This section we're going to look at evaluating and graphing polynomial functions. So here's your evaluating by definition, a polynomial is f of x, a x. All right, there's your definition, and here there's a couple constraints. Your a sub n cannot be 0, and your exponents there are always whole numbers. Okay, so all your exponents are whole numbers, and your coefficients there are simply real numbers. Okay, so your exponents have to be whole numbers, your coefficients are real numbers, a sub n cannot be 0. So let's take a look at some polynomials that you're probably very familiar with. Their degree, the type or classification for that. And then their standard form. Let's throw in an example too. An example as well. Okay, so first of all, let's look at a polynomial of degree 0. Okay, polynomial of degree 0. Well, if you think about this, if you're n up here, up above in this x to the n, you see the a to the n, x to the n. If your n, your degree there is 0, that'll clear out the x becomes, well, x to the 0 power is 1, okay? So the type is that's a constant, okay? That's a constant. So you're just looking at this very end piece, if you will. So f of x equals a to the 0 is your a to the 0, okay? You're just a constant. For example, y equals 6. It, of course, is a horizontal line, okay? That is a polynomial of degree 0. We call that a constant function, okay? Let me again go to the side. I think, okay, that means your x power, let's say your coefficient here is 2, or whatever it is, x to the 0, right? Well, we don't bother with the x to the 0 because, again, that is 1. So there's another constant function, y equals 2. Okay, so your degree is 0 there for that one. All right, let's look at another one here. Let's go with a degree 1. We call this linear. Okay, way out there, linear. F of x equals, in your typical form here, a1x plus a sub 0. Okay. Okay, a lot of the time you guys probably remember that mx plus b, right? Your m here's your a subscript 1 there, that's your slope, and your a sub 0 is your constant portion. So like f of x equals 2x plus 7, for instance. Okay, that's an example of a linear polynomial function. You see how it's x to the 1? You see where I just wrote in that 1? So your degree is 1. Let's go to degree 2. We've been working with lots of these lately. Quadratic. So your standard form would be f of x, a2x squared plus a1x plus a0. An example of that would be, let's go with f of x equals negative 3x squared minus 6x plus 7. Okay, there's an example of a quadratic function, degree 2. You see how it's x to the 2 there in your very your initial, see that x to the 2, degree 2, right? So that's also a polynomial. Let's go degree 3. Call this cubic. Cubic function. So f of x equals a3 x to the third plus a2x squared plus da 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 down to the end, down to that a sub 0 at the end, okay? And that would be like f of x equals, let's go with 6x cubed minus 2x squared. And let's skip the something x portion and just throw a constant on the end, minus 7. Okay, that's still a cubic function, even though you're missing the such and such x piece there, okay? Or even just f of x equals 6x cubed. That's a cubic function as well. You notice all of these have real coefficients, and their degrees, they're all the degrees are to a whole number there, all the degrees, okay? Let's go one more. Let's go a fourth. That's a quartic. Quartic f of x. There's an example. Negative 13. Let's go x to the fourth. You know what? Let's just forget about the rest of that. Okay. So your degree, anything of degree n, and the type would see, if you want to say, like, let's say you have a 6th degree or no, a 16th degree for n. Okay. So you're looking right here. If your degree is 16, you say that's a 16th degree polynomial. Okay. So that's the type here, nth degree. Okay. Your standard form, we already stated that in the definition. And again, it depends on your degree there. Okay, so that's a little table on these polynomials. Let's see if you can decide whether the function, let me pull up a new page here on my board. Decide whether the function is a polynomial function. If it is, write the function standard form and state its degree, type, and leading coefficient. Okay, so for example, is this thing a polynomial? F of x equals 2x to the 1.2 plus 2x cubed is 2x cubed minus 4x squared. So you look at that and you say, okay, are all the coefficients real numbers? Yeah, those are okay, right? All those coefficients there are all the powers, right? The degree of this, the powers are all whole numbers. You're like, uh-oh, that's not. So this is not a polynomial. Okay? You know, that part's okay. That part's okay. Again, it's the 1.2, that's your issue there. So that's why that is not a polynomial. Okay? Let's look at another one. Let's go off to the right here a little bit. How about f of x equals 1.2x x squared minus x cubed plus 71. Let's go with that one. Is this a polynomial? Well, let's see. All the coefficients here are real. Looks like they're all real numbers right there. And my degrees are all my degrees whole numbers. Yes, they are. So I say yes, this is polynomial. Okay, let's write this in standard form if it is. So in other words, you take your largest degree, you got to write that thing first. So negative x cubed plus that 1.2x squared plus the 71. You notice there's no something x term there, is there? It jumps from that squared to the constant, and that's okay. So here it is. It's a polynomial. Here it is in standard form. What kind of a polynomial is it? It's a third degree, so we call this a cubic, third degree, right? Third degree, cubic third degree, okay? So the degree is a 3, the type is that it's a cubic, okay? Let's go, you know what, let me do one more here I'm looking at. How about f of x equals negative 0.5x plus pi x squared minus root 2. Is this one a polynomial? Negative 0.5x plus pi x squared minus root 2. Are all the coefficients here real numbers? Yes, they are. In other words, no imaginaries or any, none of that. Okay. All the degrees, whole numbers. Yes, they are. X to the 1, x squared, right? So this, yes, even though it looks kind of funny, yes, it is. Let's go ahead and write this thing in standard form. So there's your largest degree, right? This is a quadratic. So you write the pi x squared. Your leading coefficient there is pi, degree 2, x there squared, minus 0.5x, and then minus root 2. Okay, so this is a quadratic degree 2 polynomial. Okay?